So in this lesson, we're going to talk about graphing and how to graph equations that are in factored form, quadratic equations in factored form. Before we begin, it's important that you understand the very fundamental basics of graphing. There's two types of graphing. One is where you graph point by point, and one is based more on recognizing the patterns of whichever equation that you're working with. Graphing point by point takes a long time. It's fairly inefficient. However, it is the basics, and a lot of what we understand about graphing can be understood by looking at the patterns that certain equations give when they graph point by point. I'm going to be going over both here in a moment, but what I'm trying to say is if at any point you forget how to graph using just the structure and the pattern present in the equation, you can always graph point by point because that will be the same regardless of which equation you're working with. Okay, so how do we graph point by point? This is something that is usually taught either in elementary school or in middle school. And essentially, what you do is you create points and then you plot those points. And the way you create the points is you determine their coordinates. So a point has an x coordinate and a y coordinate. And when you're dealing with a function, like this function, for example, the x coordinate is the independent variable. And what that means for us is that we get to choose, as the mathematicians, we get to choose what the x value is. And then the y value is the dependent variable, meaning it depends on whatever we chose for x. So we actually don't get to choose the y. The y will be calculated based on whatever we chose for x. It'll have an automatic value that goes with the x. So to graph point by point, it really is just a matter of selecting an x value and then calculating out the equation with that x value and solving for y, and whatever that y is becomes our y coordinate, and then we plot. A lot of times this is taught using a table. So you can choose your x and then calculate it out and you get a y, and then you can find your points that way. For the purposes of this explanation, this isn't really to explain how to graph point by point, but I'll give a couple of examples how we can do that. So let's say that we chose x to be 1. So in the event that we choose x to be 1, we substitute all of the x's for 1s, meaning we will have an equation like this. And then we can use the order of operations to simplify the right-hand side, 1 minus 3 being -2, 1 plus 6 being 7, and -2 times 7 being -14. So we get the information that y equals -14, and that gives us our y coordinate. So then you can plot this point, 1, -14, it'll be somewhere 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It'll be like around here somewhere. And that will be that point. Just so you can see it again, let's select a different number. For example, let's go ahead and choose -3. See what we get there. Again, we rewrite the equation, replacing x with the x value that we chose, in this case, -3. Use the order of operations to simplify. -3 multiplied by -3 is -6. -3 plus 6 is going to give us 3. And then -6 times 3 gives us -18. And so we get that point, -3, -18. And that's graphing point by point. You could make the entire graph just plugging in each different value for X and solving for Y and calculating out, plotting those points. Like I said, it takes a long time, not very efficient. Something to be said though, is that when you are selecting an X value, the concept behind selecting an X value, one of the things that you're doing is you are fixing where on the X axis your point is going to be. By selecting X to be 1 in the first example, I am guaranteeing, I am fixing that my point will be somewhere along this line where X is 1. Because I selected X to be 1, I know the point will be along this line. Similarly, in the second example, when I selected X to be -3, I am guaranteeing that X will be along, or excuse me, that the point will be along this line where X is -3. That's something to keep in mind for later. It's one of the things that we're going to use as we graph our equation. Okay, when considering graphing equations in factored form, it is seen as easier and it is easiest to consider the x-intercepts. The reason for this is because x-intercepts all follow a pattern. So x-intercepts, by their definition, have to be points that are on the x-axis. And all the points that are on the x-axis have something in common. And that is that regardless of what the x is, their y-coordinate is 0. So any x-intercept that we can select, any x-intercept that we might find, will have a y-coordinate of 0. There's just no way around that. So knowing this, we can actually preset the y value in our equation to be 0. And what this tells us is that any x that we find is going to be whatever x makes our y coordinate 0. In other words, any x that we find will be the x coordinate of our x-intercept. Okay. Now consider the structure of the equation on the page now. You have two items that are multiplying together and they equal 0. The only time this happens when you can have a multiplication equal to 0 is if one of the factors equals 0. So either, there's two possibilities, either this parentheses equals 0 or this parentheses equals 0. One of those must be true. And sometimes it's the case that both are true at the same time, where they're both equal to 0 at the same time. But in this case, it must be true that either this is 0 or this is 0, which will then multiply to the other parenthesis, make it 0, and give us our answer. This property is called the zero product property. And it allows us to break up this problem and solve, instead of solving it all at once, we can actually solve each chunk. So there's two possibilities that are going to lead to two answers and two x-intercepts. So either x minus 3 equals 0, which means x can equal 3, or x plus 6 equals 0, which means x can equal -6. In either case, whether x is 3 or x is -6, we already know the y coordinate to be 0. So we know there are points 3, 0 and -6, 0. So that's going to give us our x coordinates, our x-intercepts, excuse me, here at 3, 0, and then again here at -6, 0. Okay, let's try another problem. Okay, this time I've written a different equation, and we're going to find the x-intercepts to this equation. So knowing that we're looking for x-intercepts, we can replace this y with a 0. And then we can solve for x. Since we have an instance of the zero product property where two items are multiplying to be 0, we can set each one equal to 0 as a separate possibility and then solve. So x minus 2 could equal 0, which means x equals 2, or the other possibility, x plus 4 equals 0, which means x equals -4. Since these are the x coordinates that would give us a y of 0, that leads to 2 points, 2, 0, and -4, 0. And these are our x-intercepts, 2, 0, and -4, 0. Now, because this is a quadratic function, meaning there's an x multiplying an x, there's an x squared term built into this function, the graph will be a parabola. And parabolas are these U-shaped graphs. They're either pointed like this or pointed like this, usually. There are some other types of parabolas, but for our purposes, they're usually either pointed up or pointed down like so. And they're symmetrical, which means if you draw a line down the center of them, every point on the right-hand side has a matching point on the left-hand side. So because we have here two x-intercepts, we know that one belongs to the left side of the parabola and one belongs to the right side of the parabola. Using these 2 points, we can find what's called the line of symmetry or the axis of symmetry, spelled like this. And what the line of symmetry or the axis of symmetry is an imaginary line it's a line that can evenly divide the parabola into 2 sides that mirror each other, so that every point on the left-hand side of the line of symmetry has a reflection image on the right-hand side, or vice versa. They are both the left and the right-hand side are reflections of each other. And what this allows us to do is to find that center axis of symmetry, which we see here is at x equals -1. And since we know x equals -1 is the center of the parabola, then we can use that to find the vertex of the parabola, the turning point, because the vertex is also in the center of that parabola. It's in the middle. So what we want to do, we want to find a point that lies on this middle line at x equals -1. So we can come over to our equation, set it up again with y, and we don't need these pieces anymore. And we can substitute in -1 and just see which y coordinate we get. And that's going to give us a point that should be on that axis of symmetry. So we're going to put y equals -1 minus 2, -1 plus 4. -1 minus 2 is -3. -1 plus 4 is +3. And -3 times +3 is -9. So since we selected the x value of -1 and we solved it and we got a y value of -9, we are given the point -1, -9, which is -1, 3, 4, 5, 6, 7, 8, 9. It's right here. Since we know that this line, this dashed line, represents the axis of symmetry, represents that middle of the parabola, we know for a fact then that this is the vertex. In order to find some more points what we can do is focus again on the intercepts. So in a very similar way to how the x-intercept has a y-coordinate of 0, as I discussed before, where all x-intercepts follow this pattern, y-intercepts follow a similar pattern but instead the x is 0 and the y value could be anything. So if we use this knowledge for the y-intercept, we can substitute in 0 into the x and get a point on the y-axis. And that's going to give us our y-intercept. So let's do that now. We get y equals 0 minus 2 and 0 plus 4. 0 minus 2 is negative 2. 0 plus 4 is 4. And negative 2 times 4 is negative 8. So we substituted in 0 and our y is negative 8. That means we get a point here at 0, negative 8. Since we know that the vertex represents the center of the parabola, and that's the center line, and we know parabolas are mirror images left and right, and we know furthermore that this is a point because we just figured it out, we can then mirror this point to the other side and say there must also be a point here. And that's true for any point that we find. So if I find a point over here on this x value, let's say I substitute in 1, that's going to get me this value here. If I substitute in 1, it'll be 1, negative 5. I can then mirror that, knowing that this is the center. Knowing that this is the center, I can mirror that over to the other side and know that that's a point as well. So using a combination of mirroring, knowing the intercept and the axis of symmetry and the vertex, we can effectively graph factored form functions without having to graph point by point. I'd like to go over another example of graphing. In this example, I'm going to simply graph as I would normally, explaining some things along the way, but not going into quite as much detail as I did the first time. So the first thing I would like to do is to graph my y-intercepts. Excuse me, my x-intercepts. In order to do that, we're going to set y equal to 0 and then solve. Using what we know about the zero product property, we have two items, two parentheses that equals 0 when multiplied. Therefore, one or the other must be equal to 0. So possibility number 1, x plus 6 equals 0, which then means that x equals negative 6. And that leads us to the point negative 6, comma 0. 6. The other possibility is that x plus 4 equals 0. Which leads to x equal to negative 4. And that gives us the point negative 4, comma 0, which is here. We have 2 points and they're mirrored of each other, which means we can now find the axis of symmetry. We can find the center value. We know this is at negative 4. We know this is at negative 6. The axis of symmetry, therefore, must be at x equals negative 5. Since we know the axis of symmetry equals -5, we can then use that to find the vertex, which is also in the center. To do that, we're going to substitute in -5 into the equation. Let's revert it back to y, since we are no longer trying to find our x-intercepts. And we know y equals -5 plus 6. That's -5 plus 4. So because we knew that the axis of symmetry was at -5, we know the center is at -5. We can substitute in -5 in for x. That's going to give us a point somewhere along this line. And whatever that point is will be the vertex. Solving this, we get -5 plus 6, which is 1. And -5 plus 4, which is -1. And -1 times -1 is +1. So when we substituted in -5, the answer we got back was 1. So -5, 1 is right here. Now we can select other points and calculate them and then mirror them to the other side. So let's go one more over from -4. Let's say -3 and find a point along this line. So let's substitute in -3 into the equation. Okay, -3 plus 6 gives us 3. -3 plus 4 gives us 1. And -3 times 1 equals -3. So since we plugged in, we substituted in -3 for x. And the y value that we got out was -3. That gives us the point -3, -3, which is -3, -3 right here. Since we know that the vertex symbolizes the center of the parabola, we know we can mirror this over to the other side, which is here. So to finish the graph, you could find other points and mirror them. And that's how you graph equations in factored form.